One, two, 1, 2. Okay. Hello, everyone. First of all, I would like to thank you for choosing to stay with me here today and devoting your time. I will try my best to not waste it for you guys. So my name is Michał Stradowski, and I am Senior Software Manager at Dell Software R&D Center here in Poland. And yes, you heard it right. There is a software part of Dell. We don't just do laptops and monitors, keyboards, mice, and servers. Yeah, we also do software. But I'm not going to be talking about our portfolio, about the projects we do at Dell. I'm going to just mention that I'm working at PowerFlex, which is a software-defined storage product offering that we have. And I encourage every one of you to check it out if you haven't heard about it. And if you want to know about the products or projects we do that are software-related or software-only, then come over to our stand, and I will be happy to tell you more about those projects myself. So what will be covered here if we're not going to be talking about Dell and their products? So first of all, we're going to try to say or define what is a test double. And that's going to be a very basic definition. I'm not going to focus too much about it. And then what are the main types of test doubles? Then I'm going to try to describe a real-life situation based on the real project, loosely based on the real project. That's going to help explain the implications of implementation of test double techniques in large organizations. Then we are going to discover our first aha moment of this presentation. And hopefully you're going to notice that with me as well. And by that point, it should be obvious to all of you why I chose this topic and why it's important for us at this moment. Then I'm going to try to give some closing thoughts and leave you with some questions so that you can think more about it once you'll be going back home or on another presentations. So I also like to say what we will not cover here. So I'm not going to show any code snippets this time. I chose this presentation to be less technical, more soft. Wanted to try something new. So I'm not going to be demoing any products. I'm not going to be giving you any instructions on how to do stuff or what are the best ways to use test doubles. I'm also not going to give you any recipes for a secret sauce, how things should be done. So I'm not going to tell you what should you do or what should you not to do. And I'm not going to spill any trade secrets of Dell about new or existing products. So if any of you was hoping for that, and I see this guy was, then I understand that you're going to be leaving. So that being said, let's try to establish what is a test double. So I'm sure most of you know what is a test double and who is this guy there on that picture. But do you know who is the guy on the right side? And no, that's not me. So this other guy is a stand double, and I guess stand double to me is the best way to explain what is a test double. So you use a stand double in order to get to perform some actions or activities that otherwise would be very difficult or even dangerous for the actor to do. This way, without harming an actor, you can do a bunch of crazy stuff, and everybody's happy, except of wife of this other guy if he dies. But let's not talk about him. So a test double allows us to decouple the application from unnecessary dependencies. It lets developer focus on developing code and not worrying about additional overhead that comes with many multiple dependencies in the application. So there are many different types of test doubles, and mostly they are being categorized as mocks, stubs, fakes, dummies, spy, and virtual services. Now, even though those names may sound nefarious, they are quite easy to understand. And to me, it doesn't really matter what's the difference between a stub or a mock. And also, there is a lot of debates on Stack Overflow. There's a lot of Medium blogs that try to explain what is what. There are books about it, so I'm not going to even try to attempt to pretend I know better. But if you want to have a chat and understand or learn what I think is a mock and what I think is a stub and what's the difference and does it matter, then again, join us at our stand, and I'm happy to have a chat about it with you. So let's talk about the implication of implementation such techniques in large organizations. It's going to be very easy to explain that if we're going to talk about some specific example. So let's say we have a project, fairly large one, 100, 150 engineers working on it, multiple different value streams, multiple different features, multiple different components. all depend on each other. Sounds quite normal and familiar, right? A lot of you guys probably work in projects like that. In those projects, those dependencies could be different components of the application, could be APIs, databases, network, hardware, you name it, right? And that still doesn't sound too bad, right? We saw those in actions, we work in those projects, so it shouldn't be too scary. But some of those dependencies may not always be available to you, especially in your dev or test environments. You may not be able to access production database. You may not be able to access some hardware easily. You may not have the same amount of hardware in your dev or test environment as you would in the production for various reasons. Some of those dependencies may not be yet developed. Some features may be still in progress and you are just waiting for another teams to finish them. Third parties may own them, and obviously it's going to be difficult to use it in dev the same way like you do in production. They may be hard to access, like I mentioned. They may be problematic to set up. They may need a lot of additional effort for the developer to be able to set up on his sandbox. Especially for us, it's a true situation at Dell. If we're building storage solutions, it's going to be difficult to build entire server infrastructure on your sandbox machine and be able to test all of the things that you need. So they may be also very expensive or highly restricted, so you will not even be physically able to access them from test or dev environments. So it seems there's a lot of effort and resources required in order to be able to work normally in such a project, to be able to perform every action and interaction that developer or tester would need. The developers in this project would quickly start getting frustrated, obviously, by that, because they would be spending a lot of the time trying to work with the overhead of the implementation of those dependencies, frustrate that some of the things are not ready, databases are not accessible, etc., etc., and they would not be able to focus enough of their attention on the functionalities. It's going to eat their time. It's going to lower the productivity of the entire team, and slowly business is going to see that our applications are not developing as fast as they could. And above all, it's going to kill the fun of building new functionalities for the developers, because they're going to be constantly compiling, configuring, and messing up with some stuff instead of building new features. So luckily, we know the solution, right? We just talked about stand doubles, stand doubles. We can replace all of the dependencies with those test double objects. We can start building those and isolate ourselves, isolate our work from all of the nasty dependencies we know that we have. So once we figure out which type of a test double is good for which of our dependencies, we can start building those. And soon we're going to have in the team a lot of developers building their objects. That's going to be basically helping them get rid of those dependencies, get rid of this overhead, and finally do their job. So build the functionalities that they need. Simplify the complexity of the development process. So now the developers no longer complain. They can work. Everything is fine, or this seems to be fine. They don't have dependencies on hardware, on unreliable applications, APIs, databases, you name it. Even organization is happy because they no longer need to worry about preparing the resources for dev and test environment, because some of those expensive and heavy resources would not be needed, because we would have stubs, we would have mocks, we would have test doubles to replace them. So everything should be fine and everybody are happy, right? It usually can go so far that we actually will end up with a bunch of objects, testable objects that are built by different developers in the team, and they would be bundled together in a framework. Framework which would be basically capable of simulating most, if not every, dependency or component in our application. And that also sounds cool. And basically, we could end the presentation here, right? We identified the problem. We figured out that there is a technology that can help us, or a solution that can help us. We started to build those testable objects. We test that, it's working, job done, problem solved, right? What? 11 minutes presentation done. But now is the first aha moment. So even though we solved this problem, we kind of created a new problem for ourselves as well, right? So we now have this fabulous simulator that can do all that magical stuff, that can mimic all of the dependencies. We don't depend on anything. We're happy. Everybody's happy. The complexity disappeared. We show it to our other developers. Everybody is using that now. Even testers are happy with it, and they are using it to do their testing scenarios. New joiners that come to the team starting to be introduced to it, and that's quickly becoming a critical part of our development process, right? Everybody uses it, everybody knows it, everybody depends on it. And with that comes a real question. So how to keep it still relevant for the application? Because obviously the application is still being developed. Things are changing, new components are being added, so our simulator should also be developed with it. But who should do it? Who should be responsible for it? How to manage it? How to maintain it? Should somebody manage it, or can we just leave it and it's going to naturally, on its own, survive? Right? So why did I choose this topic? Well, basically we are actually at in the project I'm working on, asking ourselves that question. In our project, we do have a lot of dependencies on hardware, on other components that we otherwise cannot use naturally or easily in dev or test environments. So we figured out we can build that simulator tool. And we also figured out that with that, we're going to help a lot of other folks in our teams, in our organization. So much so that not even testers or developers can use that simulator, but our sales team could even use it to demo it to our clients so that they can show them how complex this application can be, how you would be able to easily manage your storage, etc., etc. So at first, we thought, okay, we need to continue to maintain that. We need to manage it. So, hey, let's create a simulator team. We're going to assign a couple of developers to it. We're going to ask them to own it. We're going to give them the responsibility that comes with it and further develop the simulator, while all the other developers will still continue in doing their job on an application. So we have testers doing their testing, developer doing their features. If and when they need new feature or new implementation on the simulator, they will just drop a ticket to the central team, to the core team, to the simulator team, and the guys will surely do it, right? So that sounds also good, right? But, and yes, there is a but, and there's always a but. So we have that team, we have entire application and project depending on it, we have a bunch of requests for new features. So is this team going to be able to sustain all of that? Is this team going to be able to deliver on time everything? Is this the right approach? How big should be the team? How to explain to the business that we need to put that effort on something that they will not directly sell? There's not going to be a direct income from that simulator tool. So we're again facing another issues and another questions, how to make sure that this project or this team will be able to succeed and do whatever we need from them on time so that they will not become another big bottleneck, and we're not going to replace a bunch of small dependencies with one huge dependency on one central team that's not able to deliver on time for us everything that we need. And I'm sure some of you also can get familiar with that situation where you were in the project and you had to depend on some team to set something up for you, and it was always busy team. Everybody were asking them for something and they never did it on time. So you really don't want to be in that position, and you really don't want to go there. So there has to be a better way, right? Surely it cannot be either we simulate all of that and end up with a central team that's going to be one big dependency, or we don't and we get up and we get back to the situation when we were frustrated with not working dependencies. So what can we do? What else is there? If on one side the central team that manages the simulator is not the best approach and it has a lot of complications and complexities, then maybe there is something on the other side of the spectrum. Maybe the other option would be an open source approach. Maybe we should just open source this simulator and let the community take care of it. We don't have to worry about it. There's no central team. There's a huge community that's doing that. So maybe this would work, right? But chances are because it's a simulator tool and it knows a lot about the interactions between components that are depending on each other in your application, and it is commercial application, you may not be able or allowed to do it to make it open source, because it would just basically spill a lot of companies' trade secrets about how your core application is working and interacting with other components. And that's actually the case for us. It's impossible for us to open source that, and it's impossible for us to basically make it common. Plus, I don't know if anybody else would be happy to use it, because it's a very specific solution to our actual project. So if we cannot make it open source, maybe we can fake it open source. So instead of truly make it open source and putting it out there publicly, we have a community of 100, 150 engineers in the project. Maybe we can put all of that code on the repository and let this mini community take care of the rest. They would naturally develop new features on it if and when they need them. Once they're building functionality on the application, they will also update the simulator. Sounds like maintaining your unit tests, so should be kind of doable for everybody. So we have the idea. Sounds like something doable, at least in theory. Follow the open source model, but keep the code internal and private. So now we have two options. We have two extremes, two sides of the spectrum, each with its pros and cons, but at least we can analyze them and figure out which sounds better to us, whether we should open source kind of open source approach, or whether we should go with the central team and closed sourced approach, let's say it. But maybe we don't have to choose one or another. So is there something called a golden mean there? So what is the golden mean? And I'm surprised myself to say that, but I'm actually quoting Aristotle here. He's not a programmer, or at least he wasn't, if I check it correctly. He had this notion that golden mean is understood to be a desirable middle between two extremes, one of excess and the other one of deficiency. So obviously we don't have excess and deficiency here, but we do have two extremes. So we, on one side, have open source, on the other side, have closed source approach. On one side, we have power to the people, let everybody manage their code. On the other side, we have central team that's going to be managing all of that. So it kind of sounds like a golden mean concept from a Aristotle's perspective. So what Aristotle said is that in order to find the true virtue, which is true middle between both of those extremes, you need to experience both of those. So you need to be very poor, and then you need to be very rich, and this way you will be able, what is the best, middle for you. So for us, we would have to be very, very centralized with our approach on one side, and then try to be very, very open source on the other side, and then experiencing and knowing both of those sides, we would be able to somehow find the perfect balance. Now, I don't know organization that would let me do that experiment in real life and spend time and money to actually play with Aristotle theory on a live production environment or a product that they're selling. But luckily, in our case, we exactly know how the first option looks like, because one of our QE teams a couple of years back developed a framework that should supposed to help testers and aid testers with their work. And they went with a central team approach. So they created a framework, they created a central team. It all worked fine, nice at the beginning, but with time, obviously, this functionality or this framework was not developing fast enough to cater for new needs of the application and the testing team. And especially when the new joiners come in, when the new developers came in, and they saw this, they didn't understand why we are using such a outdated framework that doesn't do too much good to us. They didn't remember, or they didn't know about the historical problems pre-framework. They didn't understand the history behind it, and they were refusing to accept that this is the norm, and we have to kind of go with that. So on top of that, you have, again, your QE teams that's slowing down because the central team is not able to do their job fast enough, and it's not their fault. It's just the situation. You have 100, 150 developers doing new features, similar number of testers testing those features, and obviously a couple of people in one team cannot cater for all of their needs. So it was destined to fail. What we don't know is what we don't is how it will look like if it would be kind of open source. So what we figured out is we're gonna try to give it more like a power to the people. We're gonna get this simulator framework ready and release without a central team, build it so that it's self-service. Every developer can interact with it. Every developer can use it and can make changes on it. And we're gonna observe how it's gonna, survive over the time. And if and when something's not gonna work, then we're gonna move it slightly to the other extreme, which is put it more central, give some ground rules, give some control, limit some access, etc., etc. And this way, hopefully, we will be on our journey to find our golden mean for this simulator. So, remember at the beginning I told you what this presentation is going to be about. I also told you what this presentation is not going to be about. And I told you I'm not going to tell you any secret sauce how things should be done. So if you ask me how developers can work with test double, I'm going to tell you I don't really know. I'm trying to discover it myself, and we're trying to figure that out on our project ourselves. But I would be very interested to hear your opinion about it and your experience from your projects. How did you interacted with such a tools and such a situations? Did you had an experience working with central team that was great and helped you with everything? Did you maybe had some other problems, or do you have maybe other ideas how this can be done that I didn't mention? So I'm asking you, how developers can work with test doubles? Yeah, I'm asking you. Yeah. Mm-hmm. Great. So you have fully staffed dev environment. And if there is new thing being developed, new feature, then I'm assuming developers will also prepare stubs for that and put it on the dev environment, right? Great. So you kind of went with an approach that developers are responsible for maintaining their stubbed environment. Cool. And do you have any dependencies on hardware as well, or do you have just dependencies on endpoints, APIs, and databases? Okay. So you have just a bunch of stubbed APIs on dev. Okay. So that sounds like it perfectly works for you. Thank you for sharing. Anybody else? Guys there are talking, but I don't hear. Mm-hmm. 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 Trade-offs. Yeah. Yeah, yeah, yeah. Definitely, a lot of the times you will hear that being able to interact with real production data is the best approach, right? So if you can get that data frequently enough, and you will be able to be always. Yeah. But what if you have to do some tests and perform some tests before your application is going to basically be launched and running? Yeah, yeah. But you see, there's one project, second project, and all of the approaches are different. So that's why I said that I think there's no one answer. Hmm. Yeah, it desynced basically. Yeah. Always. Yeah. Pointing fingers, who's to blame? Yeah. So one of the hidden. Exactly. And one of the hidden kind of messages from this presentation, I hope that it is somehow clear, but I'm going to try to make it clearer, is that one part of the problem is to solve your dependencies. The other part of the problem, or the other question that you should ask yourself, okay, I solve them now, but will they be solved tomorrow as well? So how to make sure that I'm not going to have to do it again and again? Obviously, we can come back and we can adjust our mocks, adjust our steps, but how's that different from what we were doing before? That's still manual action that we need to do again and again and again. So if I'm hearing somebody saying to me, oh, we mocked, stopped everything in our project, sorry, that's great. But I'm always asking myself a question, how are you keeping those steps up to date? Is there an option, or is there space to improve and make sure that we do it once and it's gonna stay correct? So I know there are tools that can generate for you from your services the mock request response. They can record request response after first deployment, and then you have kind of a step that you can use, and it's going to happen automatically. But that's limited to probably API communication. You're not going to be able to do that effectively or very easily with dependencies on databases. Creating fake databases is one of the options. Creating virtual services is one of the options. There's a lot of solutions, but again, the question should always be, okay, so I solved the dependency now. How can I make it stay solved in the future? So if any of you in the future are going to be building testable objects, don't think your job is done because you built the object. Figure out whether it can on its own stay relevant indefinitely, hopefully, or at least for a long period of time. And don't forget to mention that you made small changes in your interfaces, because that's always the problem. Okay?